Today we're going to talk about introduction to matter, and we're going to focus on mass, volume, and density. This is primarily on PS2, which is finding mass, volume, and density of a substance, and then you're going to be able to calculate and compare the substances. Our essential question goes at the top of your notes, just like we talked about in the previous flipped classrooms, and it's what properties define matter. When you come in, be ready to do this. You're going to be in groups, and you're going to have several small objects, and I want you to describe the size and the shape. You're going to write a short description of how these objects are similar and how they're different, and you're going to choose one person from the group to be willing to present their findings. So be ready for that. Okay. So let's get started with the notes. Remember, anything in red needs to be written down. So the first thing is matter is anything that has mass and takes up space. Okay. So your body's matter, but light and sound are not. Okay, light and sound are energy. Your body's matter because it has mass and it takes up some space. Mass. So this goes in the section of what is mass. Remember, anything in the red needs to be written down. So mass describes the amount of matter in an object. Okay, because that's the first thing we need to understand is what mass is. Mass is how many atoms, how much stuff is you're made of. Okay, we measure this in grams. Okay, so in science it's always done in grams, and that's the common unit for mass. Objects of the same size can be made up of different amounts of matter, though. Okay, and we're going to talk about that on our next slide. So weight is a measurement of the gravitational force of an object. So weight's different. So our topic for this one is how is mass different from weight? And it's different because weight is how strong gravity pulls on an object. So if you think about the moon, right, you weigh less there because gravity is less, but here on Earth you weigh more because gravity is more. It's not like you've lost matter, okay, if I went from the Earth to the moon. It's just about the gravitational pull. So the greater the mass of an object, the greater the gravitational force on an object will be, and so will the weight. Mass stays the same for an object even when it increases or decreased by gravitational force. Change the weight of the object. So that's what we kind of talked about. So the weight of the object can change because of gravity. Mass never changes no matter where you're at in the universe. So this is one way we've already practiced doing this in the beginning. A triple beam balance is how we measure mass. And it's used by using a countermass, and we'll demonstrate that on Tuesday. Weight is measured with a spring scale. We're going to be using those later on in the year. And our standard unit for scientific weight is written as 100 grams mass, which basically is what we call 1 Newton. This slide's all about how is the amount of space occupied by matter measured. And we measure it in volume. Okay, the vocabulary word here is volume. And that's simply the amount of space an object takes up or occupies. So a balloon and a bowling ball have the same size, and they're probably going to have the same volume, but their masses are very different. So a balloon mass won't be as much as a bowling ball, but they might take up about the same space. So how can volume be determined? How do we measure volume? So an object's volume can be determined by formula, very easy one you probably learned in math, and it's for a rectangle or a solid, any type of rectangular solid that has sides, volume equals the object's length times the width times the height. And this is the formula down here. Volume equals LWH, which stands for length times width times height. Liquid volumes is measured with a beaker. Okay, so if I'm looking at anything liquid, we use a beaker or we can use a graduated cylinder. And it's usually done in liters or milliliters. And every milliliter equals 1 cubic centimeter. One way we can find a object of a rock that's not the right shape, what we call our irregular shape, is displacement of water in a graduated cylinder. So if you put it in a graduated cylinder full of water, you can find the volume of a regular shaped object by seeing the difference. So here's a good example. So first, take a look at how many milliliters of fluid does this object displace. So here's the beaker without the rock and the water. And then when I put the rock in there, here's where it is. If you said it displaced 5 milliliters, you're correct. That means the rock, okay, is 5 cubic centimeters. That's the volume it takes up. Density, okay, is measure of the amount of matter in a given volume. So density is, we're going to relate volume and mass. with density. So density of the substance remains the same no matter how much of the substance you have. So if I have water's density will always be the same here on Earth as it is on the moon or anywhere else in the universe. Iron, if I took iron and I measured the mass and the volume and calculated the density, it'd be the same here on Earth as it is on the moon or the universe or Mars or anywhere else. Density never changes. It's one of these properties of matter that identifies usually what it is. So we calculate density, okay, is mass divided by volume, or D equals m/v. Okay. Common units for expressing density are grams per cubic centimeter. So this is the way we write density. Now water has a density of 1 gram per milliliter. So anything that has a density greater than 1 gram per milliliter will sink in water, and objects with a density less than 1 gram per milliliter are going to float in water. So if you take a swimming pool and you put the beach ball in the pool, it's going to float, and that's because the density of that beach ball is less than 1 gram per milliliter. But if I put a rock in the swimming pool, that rock is going to sink because it has a density greater than 1 gram per milliliter. So you're going to do a lab. It's called Exploring Lab Comparing Buoyancies, and you're going to relate buoyancy with making a density column of 4 or 5 liquids. You're going to take rubbing alcohol, you're going to take water, corn syrup, and vegetable oil, and you're going to have to calculate the density, okay, of the objects or the liquids, and then figure out how are you going to pour them into a cup with the greatest density at the bottom and the least dense material at the top. Okay. We'll talk more about this on Tuesday. That is your lab. Please have your flipped classroom notes complete so we're ready to go.